Hello everyone, welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 401 binary watch. A binary watch has 4 LEDs on the top to represent the hours from 0 to 11 and 6 LEDs on the bottom to represent minutes from 0 to 59. Each LED represents a 0 or 1 with the least significant bit on the rightmost. Okay, so we have 4 LEDs on the top, 6 LEDs on the bottom, and the rightmost LED is the least significant one. Okay, for example, below binary watch reads 451. Okay, if you see the fourth LED, the second LED is on, so the value of the second LED is 2 square, which is 4. And in the bottom, if you see, the last LED is on, which is basically 2 power 0, which is 1. This is 2 power 1, 2 square, 2 cube, 2 power 4, and so on so forth. Okay, so if you see, this is 32, 16, 2 and 1, so summation of all these on LEDs will turn out to be 51. Okay, so given an integer turn on which represents the number of LEDs that are currently on, ignore the PM. Okay, return all possible times that watch could represent. Okay, if you see here, there are 1 2 3 4 5, there are 5 LEDs which were on. One combination is basically 451. Okay, if you have 2 LED as on, even in this case assume that 4 is not on and 2 is on. Okay, even in this case there were 5 LEDs which were on. The time represented by that configuration is 251. Okay, so given a particular number which is turn on, okay, we have to return all possible times. You may return answer in any order. Okay, the hours must not contain leading zeros. Okay, it should not contain leading zeros, and minute should contain the leading zero. Okay, it's just some kind of formatting in which they want the answer to be present. Okay, if you see turn on equal to 1, that means there is only one LED turned on in all these. Okay, so 1 alone can be turned on, 2 alone can be turned on, 4 alone can be turned on, and 8 alone can be turned on. Okay, again here all individual LEDs can be turned on, right? So we have all these possibilities, right? If only the minutes LED, last LED is turned on, that is 001, 002, 004, so on and so forth. Okay, so given a number turned on, you have to identify all of these things. Okay, let's say turned on equal to 5. Okay, so there were 5 LEDs which were turned on. Okay, so there are various combinations in which these LEDs can be turned on. Okay, so 1 from here and 4 from here. Okay, again this one and this 4 from here, one this LED is on, and any random 4 from here, this LED is on, and random 4 from here, 2 LEDs from top and 3 LEDs from bottom, right? 3 LEDs from top and 2 LEDs from bottom. There are n number of combinations in which we can actually turn these LEDs on. So instead of generating the combination of LEDs which were on, that would be very complex, we will approach in a reverse way. Okay, we know that the time can actually range from 001 till all the way up to 11:59. Okay, so this is the only valid time which can be possible on a clock. Okay, which is 001 till 11:59. Our, no matter how the LEDs were on, this is the time range in which our time can fall in, right? All the unique combination should fall in this time range only. Okay, so for all these time ranges, we will identify what is the number of LEDs which could be on. Okay, if you see, for this particular time only one LED is on, right? So which is the last minute one. Okay, so the problem statement boils down to number of bits which were set in this individual hours and minutes. Okay, if you see 11:59, we have to see if these bits were on. Okay, if you see, these are all 2 powers, right? So we have to basically check each number can be represented in its 2's powers, right? Summation of 2's powers in its binary representation, correct? So we should basically identify how many bits were set for individually for both hours and minutes, and we have to sum it up. Okay, so problem elements boils down to the set bits in both hours plus minutes, okay, for all the time ranges. If the set bits is equal to the number turned on, then that is one of the valid combination which is required for us. Okay, so let me show you the code. Okay, so I was just iterating, I was generating all possible time ranges. So hour is going from 0 to all the way up to the 11, and minutes is going from 0 all the way up to 59. Okay, if you just print out, you will get all time ranges 001, 002, 003, and so on up to 1159. Right now, for a given time, we have to identify how many set bits we have. So the set bits of hours and set bits of minutes we will be summing up. If the set bits is equal to the turned on, that means it's a unique combination which is required for us. So we will be just format both hour and minute in the format which they have requested us. Like hour should not contain leading 0 and minute should contain leading 0. That is what I am doing here. For minutes, if the minute is less than 10, I am appending a 0 to it, or else I am just taking the minute itself. Okay, in the end my result will contain all the times with these many bits set on. Okay, if you see the count bits, this is basic formula, basic algorithm. Given a number n, you should identify the number of set bits. Okay, so as long as my n is greater than 0, I am checking the least significant bit whether it is on or off. If it is on, then I am incrementing my count. If it is off, then my count will be same, and then I am left shifting my n. So this algorithm will run as long as my n is greater than 0. So in the end, count will contain the total number of bits which were set. Okay, if you run this algorithm, all the test cases will be passed, and it is pretty efficient solution as well. Okay, we are just enumerating from all the time ranges which are possible. Okay, so these time ranges are like constant, right? We can have only like 001 to 1159. Okay, so this is like it is a fixed number of time range, so we are not using any extra space, so there is no extra space involved. The space complexity of order of n and time complexity is big of n, where n is the range of the time which we have. Okay, that's all about this problem. If you like the explanation, hit the like button and hit the subscribe button, and I will be posting this solution in the comment section. Feel free to check it out. I will be posting in multiple languages. Even if you are coming from other languages such as Java, JavaScript, Python, you can also check out the solution. Okay, thank you.